Hello, I'm Tony Dubiel, Technical Solutions Architect, working in the Enterprise South area, focusing on DevOps and network programmability. Today I'd like to share with you a brief demo on network as code combined together with CI/CD, continuous integration and continuous delivery. And when we combine them together to create what we call NetDevOPS, we create a very powerful tool set that our customers can use to increase the velocity of introducing change into their networks.
All right, let's look at our demo setup. As you can see, we use VIRL to create a test environment as well as a production environment, both of which are using CSR 1KV routers. And what we're doing is we're going to test our code and make changes in the test environment. And then ultimately, after testing, we will promote that code into production, into these CSR 1KVs over here. How do we do that? Well, we needed to set up a dev box so that we can install a tool chain that would allow us to build our CI/CD pipeline in terms of continuous integration and continuous delivery of our network changes into, in a vetted environment into our production network. So to give credit where credit is due, I was able to take and leverage some of the existing tool set in a DevNet lab for NetDevOps and repurpose some of the containers that were used in that lab in my own lab for my own purposes, where I was able to customize it and create this tool chain. After the demo, I'll give you a link to where you can actually go to DevNet yourself and go through those labs, and you could build a similar NetDevOps CI/CD environment in your own lab if you wish. So first of all, what we needed to do was install Ansible. Ansible will be used for purposes of building code in this particular lab. I'll walk you through the lab in more detail, but at a high level, what we did was we're taking a role that was created in Ansible for the purposes of delivering configuration changes to all of our devices. So this common role is meant really to be used effectively for changing all of the devices. So anything that was more specific than that would be outside of this role. But for the purposes of today's demonstration, we're going to configure some SNMP strings, which could be a challenge if you have, hundreds or thousands of devices and you need to make changes to the community strings. This particular demo will show you a very easy way of managing that, as well as taking a look at how we can leverage the playbooks from a role and also best practice of separating code from the environment variables. So we will use inventory files and variables. So group variables at the highest level, that's where we will change our community strings for SNMP. And then host variables are actually more specific to the individual router. So we do have a host variable file for each one of these CSR 1KVs. And we'll take a look into more detail again as we go into the demo. The next component that I needed to implement, and this was borrowed from DevNet Express as well, is I wanted a GitHub-like repository. So GOGS is Go Git Service. This is an open source repository that uses the Git protocol that you can deploy, as open source freeware and use it for your own lab purposes. Now, in terms of network as code, what are the requirements for network as code? So the three main requirements are obviously we need the code. So Ansible is solving that for us. We will interact with playbooks that are constructed using YAML as the encoding to pass data. And then we have source control, which is our GOGS source control repository. And then the third requirement for network as code is configuration management. So in the dev box, we are actually archiving our configuration. So for the purposes of this lab, I enable TFTP. You could use SCP or some other available method if you'd like. But we are archiving our configurations from the routers to the dev box using TFTP and also using the archive capability in the routers themselves. So that way, if we needed to, we could take advantage of the rollback capabilities that are built into the IOSXE line. So for the purposes of a build and test automation server, we will use Drone. And Drone is another component that's available on DevNet in various labs that you could replicate as well in your own environment. So what does Drone do? So for our test environment, Drone allows us to take the code and deploy the Ansible playbooks in order to test the environment to ensure that our configuration changes are okay and that there's no adverse effect in terms of syntax or any other related errors before we merge that code from a branch that we're working from. A branch is a safe sandbox from which we can work from our repository, merging it into our main code, our master code, if you will, that we would ultimately deploy into production. And then building on top of best practice in a CI/CD pipeline, we should notify our DevOps teams, or in this case, our NetDevOps teams. And in order to do that, we're taking advantage of WebEx Teamspace and a bot that I created that has API integration into the drone server so that we can see if we fail on any iteration of code update or if our actual test environment or production environment is successful. We will see that notification as well. This is our VIRL management portal where we can gain console connectivity to our CSR 1KV routers. If you recall from the previous diagram, we depicted CSR 1 and 2 for the test environment and CSR 3 and 4 for the production environment, both of which are connected to a common management network so that we can connect the tool chain to both of those environments. Now we'll take a look at the configuration running in the CSR 1KVs, specifically the SNMP configuration, because we will be changing the SNMP strings as part of the demo. And then we also would like to highlight the archive configuration that we are using as part of configuration management. So the archive configuration will send configuration files to .92, which is our dev box, and that will give us the capability, if we needed to roll back if needed. Let's take a look at our drone configuration. The drone configuration is provided in a .drone.yaml file. Drone is critical to creating a CI/CD pipeline. It controls the testing and build automation that allows us to introduce a level of velocity into delivering configuration changes into the network, very similar to what we do in app dev with similar tools like Jenkins as example. We prefer Drone over Jenkins for network automation because it is much easier to integrate with Ansible and Python from a coding perspective. The stage 3 deployment pipeline does everything from creating a dev branch from our Git repository so that we have a sandbox to work from to test and code our test environment CSR routers. Afterwards, we will merge the dev branch to the master in the Git repository, and then ultimately deploy and test those configuration changes into the production CSR environment. Now let's walk through the specifics and how we would interact with the Ansible playbooks. The Ansible_env_test is an environment variable file where we have the credentials so that Ansible playbooks can SSH and authenticate to the CSR routers, in this case in the test environment. The site.yaml playbook is used for testing IP connectivity before we make any configuration changes. And as we move further down, we have the testing-playbook.yaml that is used to test SNMP connectivity to each one of the CSRs in the test environment. Upon successful completion of the test environment, then a notification would be sent from Drone to WebEx Teams bot so that we would see that the test environment has succeeded, and then the branch, the dev branch, would then merge with the master in the Git repository in GOGS. And then from that, we would go ahead and rinse and repeat by going through the same testing through Ansible with the Ansible site.yaml playbook, and then subsequently we would then invoke the Ansible test dash playbook to test the SNMP. But what you'll notice is now we are pointing to an Ansible underscore environment underscore prod because we are authenticating to the production CSR routers, CSR 1KB 3 and 4. And we would also be using the inventory that would point us to those IP addresses. So you can see now that the inventory dash I is pointing to host underscore prod, where previously it was pointing to host underscore test. So those were the IP addresses of CSR 1KB 1 and 2, and now we're pointing to 3 and 4. Lastly, we'll see a notification of the successful completion of the master branch and deployment into production in our WebEx team drone. These are Ansible files that we mentioned. The Ansible underscore environment underscore test, credentials for the environment sandbox, the Ansible underscore env underscore prod for our production CSR routers. Because we are using common, which is a role, an Ansible role, we have created a group variable, which is the global variables used for all of the CSR routers. So as we take a look at that, we have an all.yaml file. And as we review the all.yaml file, we can see that it includes the key value pairs for the variables that we would use for configuring the SNMP strings. So we will change the value of the SNMP string, and then that would be implemented in the test environment. And then after success, it would be deployed into the production environment. Having said that, we need to update our local Git repository or our local branch and then push those changes after committing them into GOGS, which is our version of a GitHub repository. A Git comment is required, and we will track that comment in our drone as we execute on the Ansible playbooks. We also need to push our change from our local repository running on the DevBox to the actual GOG, our version of a GitHub repository, and then we actually have to authenticate into that repository in order to make changes. Change SNMP for demo was the commit comment that we used in our .drone.yaml when we committed that change into our Git repository. Drone is now interacting with Git, the GOG server, using webhooks. So we can see Git commands being executed from drone. And then now it'll work its way down and execute on the Ansible playbook. So we have the site.yaml, which is testing IP connectivity to .90 and .91, which is the test environment. And then it is invoking the test.yaml, which tests the connectivity for SNMP. And then it'll migrate into the main.yaml from the common role to configure the community strings from the global variables, where we had changed the SNMP strings to include demo at the end. It also will do a copy run start, which would invoke an archive action that would in turn update the configuration management. So from a test environment perspective, we received a notification that that has completed. And now we have transitioned into the master branch. So again, we have Git commands being invoked from the webhook from drone to GOGS. And now we will build the Ansible playbooks that are for production. You can see that our host inventory has changed to 93 and 94, which are CSR 3 and 4, the production CSRs. And we're going through the site YAML and the test YAML and making those configuration changes, saving the running config to startup, which would invoke a configuration management activity for the production routers. And then we just received a notification in our WebEx team for the production network. As we scroll down, those were earlier tests that failed. We need to scroll down to the bottom. These are the most recent. We can see that our dev branch was successful. And then below that, we can see that our master branch was successful as well. We can click on these links to the commit log to glean information from the GOG server. And then if you click on the build log, that would take you to drone. Here we can see the changes made. We changed the community string from Feb6 to demo. So those were the changes that we made in the configuration of the global variable, which was the all.yaml file that we changed earlier. So that was reflected in our master branch now on our repository. So we do have a single source of truth, which is very important to maintain a single source of truth for all of our code that aligns with our configuration management, our configurations from the router, which we'll take a look at that as well. All of our configurations are stored in this TFTP boot directory. They do have a date and timestamp, so we can take the last save configuration and make sure that our SNMP strings were changed. So CSR 1KV4 is one of our production routers, and we can see that it says secure demo, or secure read demo and secure write demo. So that was successfully changed. And then just to validate the other production, CSR 1KV3, we'll take a look at that one, that router real quick. The tail command just reads the tail end of the configuration so we don't have to space through it. So it's just easy to get to the SNMP information is at towards the end of the startup config. So this one has changed as well. Now we'll go back some directories and we'll take a look at our role. So if we change directories into roles, common, and then task, we can look at the main.yaml file. And what we can do now is we can answer the question, what would happen if we were to make a configuration mistake in our Ansible playbooks? So we'll go ahead and test that by uncommenting these lines, which is an Ansible module for configuring a iOS Layer 3 interface. We are configuring or attempting to configure Gigabit Ethernet 4. And we could configure all of our routers with DHCP. However, our routers do not have a Gigabit Ethernet 4, so we would receive an error. And we should receive that error in the test environment as part of the pipeline. We should not introduce that error into production. So we just validate it in CSR 1KV4 that we do not have a Gigabit Ethernet 4 interface. We'll save our change, which means now we have to update our local Git repository with a git add main.yaml. We are required to do a git commit with a comment. So again, we will track the comment in our drone. And we'll just call it error in config. And we'll push that change, which will invoke the .drone.yaml file. Every time we push a change into the Git repository, it invokes that file, which invokes drone, right? So let's go ahead and take a look at drone, which is already started. It's up and running. Error in config is the drone job we are tracking. And we can see that it failed. And the reason why it failed so quickly is because it was an error that was invoked in the main.yaml file, and it did not make it past the test environment as expected. So we did receive a notification, a failed notification, and we can go ahead and click on commit.log to see if we can glean some information about our change, which was updated in the dev branch. But because it failed, it never was promoted or merged to the master branch. So we could, go ahead and resolve this configuration and then we would start a new job to make sure that we've remediated the issues. So that's a part of the the value of a CI/CD pipeline, is that we introduce that automation in not only building but also testing, right? So we can recover from failures quicker, resolve them, and then get to updating production much quicker and more often. So we can increase the efficiency of how we can make changes into our production environments. Again, I'm Tony Dubiel, Technical Solutions Architect. Um, Thank you for watching this demonstration. I have a PowerPoint that accompanies this demonstration. It goes in much more detail in DevOps, network as code, and the CI/CD pipeline. Special thanks to Hank Preston and DevNet, who provided a lab that gave me access to the applications used in this toolchain. I encourage you to check out this lab. You'll see the link here at the top of the PowerPoint. Give it a try. If you can, see if you can get it to work in your own testing lab. If you need help, reach out to me. I'm happy to help you. Take care.